Okay, as we come off break, we're going to start with mixing of some of our newer topics. So today we're going to look at a couple things. First, we're going to look at quadratic inequalities. So let's start by graphing. So we just spent a bunch of lessons talking about graphing, how to solve quadratics, and we're going to put all those together to do quadratic inequalities. Graphing-wise, this is very, very similar to what we've done before. So if we were to pretend that we are graphing y equals x squared as an example, we'd go through and graph whatever system you like, your graphing calculator, online tool, whatever it might be, but we'd get y equals x squared and we'd have that customary u parabola shape. All those rules that we've talked about before for inequalities still are in effect. So greater than or less than, we're still going to graph it with a dotted line. Less than or equal to or greater than or equal to, we'll still graph it with a solid line. So in the case of y is greater than x squared, it would be our basic y is x squared graph, but it would actually be dotted. And we'd have something looking like that. Finally, just like we did before, we're going to have to still shade these. So in my case, y is greater than that function, so we would be shading everything above it. And honestly, that's pretty much all there is to graphing inequalities. We're still going to use all the same tools for graphing we did before. Maybe they'll give it in vertex form. Maybe they'll give it to us in standard form, and we'll have to figure out what it looks like. But whatever it might be, we're still going to do it the same way. So I'm just going to show one or two quick examples of these. Let's say we'll do kind of an ugly one to start. How about y is less than or equal to x squared plus 3x minus 4. So we go to graph this. The first step, just like when we graphed inequalities before, was pretend it's just an equal sign. What would this graph look like? All right, well, it's not in any pretty format or anything. You could just dump it right into your calculator if you wanted to do that. We could use factoring to help us with this. And honestly, you have a bunch of different tools for doing it at this point. We could even do completing the square and force it into vertex format. However we want to do it. When we go to graph it, we'll end up with something that looks roughly like this. Comes down pretty far. It's going to impact over here at -4. Vertex is down around -0.5, somewhere around here, and about like 6 point something, 5, 6. So my vertex is about right there. It's less than or equal to, so it'd be a solid line coming through. We'd have something that looks something like that. Solid line because it's less than or equal to. Because it is less than or equal to, my answer is below that region. Now, I didn't show much work for how I actually graphed it. You're welcome to graph it however, whichever way you want to do. You can plot a whole bunch of points. We could do this with completing the square. It honestly doesn't matter. I'm going to show one or two of them real quick. This is kind of a refresher. So let's say we had like y is less than or equal to x squared plus 3x minus 4. And I'll do completing the square because that's one of the last things we did. 3 divided by 2 squared would be 9/4. I'd have to add 9/4 to both sides. So that's y plus 9/4 is less than or equal to x squared plus 3x plus 9/4 minus 4. This is now a perfect trinomial of the form x plus 3/2 squared minus 4, and then I'd subtract the 9 from both sides. Oh, that's why my scaling's off. I'm like, this isn't matching anything. It's because all my scaling's different. 2, 4, -6, -8. Down around there. So when we look at this now, we have y is less than or equal to x plus 3/2 squared minus 13. That's now in a nice, easy to work with format. 8, -10, -12. See, I was just a little bit off when I plotted it initially. Graph paper will be helpful. So here we'd have y is less than or equal to x plus 3 squared minus 13. This now we could actually plot a little more accurately now that I'm just eyeballing it and doing it in my head. So we have 1, 2, there'd be my vertex, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Be down here, my intercept was actually at -4. So a little bit more accurately would be something like this. And again, it would be underneath. So I wasn't too far off on my eyeball. A little too flat. So that's what we could do using making a vertex form. Remember, we could have also factored it as another option and then gone from intercepts. So there's a lot of different ways that you can actually graph these. So graph it however you can. Next, we could graph systems. What if we wanted to graph y is greater than x squared, but y is less than x minus 2 squared, less than or equal to x minus 2 squared plus 4. Just like when we graphed systems before, it just means we do it all at the same time. So I'm going to graph each of them separately. So my y is greater than x squared, so that's just our standard parent graph. It'd be over 1 up 1, over 1 up 1, over 2 up 4, over 2 up 4. And it is greater than, so it's going to be a dotted line, dotted line. And then it would be everything above it. So just like I modeled before, I'm just going to show kind of arrows so I don't have a bunch of confusing shading going on. Now if I do this one, that's left, right 2, 1, 2, up 4. And then it again would be going upwards. So let's make this go downward so it's a little bit easier to see for you guys. So if it's going downward, now this graph is going to be coming solid like this and coming down. And it would be less than or equal to, so it'd be underneath it. So now my region would be this funny, almost fish-shaped in between them. So not much has changed compared to the previous lessons. You're still going to graph each one. You'll do a dotted or solid line, and then you just need to shade the appropriate region. If we're talking about a system, it's just going to be multiple graphs at once, shade the overwhelming answer. If we're talking about a single graph, you just shade above it or below it based on the y equals. So there's nothing really new here in the beginning. What we're going to do next is talk about how to solve an inequality algebraically. And this is a little bit tougher. And like this, you have to be able to do what we did in the last couple lessons. So if I wanted to solve a quadratic inequality like this, then we have some options. So let's say instead it is to solve x squared plus x is less than or equal to 6. All right, so when we go to solve, there's really two main ways. We can solve a system like this graphically, or we can solve it algebraically. And I'm going to ask you to do both. So graphing-wise, we have a couple of options. The simplest way is to take it and make sure it's being compared to 0 first. So I'm going to take all this and I'm going to move it over. So that'd give me x squared plus x minus 6 is less than or equal to 0. Now I go to graph this equation. And you need to be a little bit more careful when we're actually solving them graphically. So make sure you're being a little bit neater with it. Again, graph paper is going to be helpful. So all I'm going to do is I'm going to pretend that this was equal to first, and we're just going to graph. That's all we need first. So in this case, this is factorable. That's x plus 3, x minus 2. So we'd have a 0 at -3, 1, 2, 3. I'd have a 0 at positive 2. And then my vertex, if I wanted to find the vertex and plot that real quick, I'm just doing the intercept method this time. If I wanted to find the vertex, I take those averages. That's -3 is one 0, positive 2 is the other. So -3 plus 2 over 2 is negative 1/2. If I plugged in a 1/2 into this whole thing, I'll get some ugly decimal, but let's see what we actually get. So we're over here at negative 1/2 is my middle. I plug in a negative 1/2 into my function to see what we get, and we get 1/4 minus 1/2 minus 6. So that's negative 1/4, so that's negative 6 1/4. 1, 2, 3, 4, 5, 6 1/4 would be down there. So our graph would be something like this. Again, I'm making it solid because it's less than or equal to. Now here's the key. So we have a basic graph. If we were just shading it and graphing it, we'd shade it like this. But it's saying that this graph itself has to be greater than or equal to 0. So we're only interested everywhere that it's actually past that 0 marker. So graphically, I'd have a solution that looks something like that. And then it would keep going off to the right as we go up. So again, we're only looking at the regions where it's actually above the x-axis. That's kind of graphically what we're doing with this. Let's look at it algebraically instead. So again, we're starting with our x squared plus x is less than or equal to 6. So algebraically, what we need to do is we actually need to figure out when is this equal to 0 first. So this is just like our earlier homeworks. So I'm going to take this is less than or equal to 0, and now I'm actually going to solve it for 0. So here this is factorable. That's x plus 3, x minus 2. I need less than or equal to 0. So if I were to just solve this, I'd get x equals negative 3 and I'd get x equals 2. So in terms of a number line where we're looking at our answers, here's 2, here's negative 3. When we did things with number lines, remember that less than or equal to, we used brackets. So less than or greater than was open parentheses, was open circle. Less than or equal to, greater than or equal to was brackets or closed circles. All this stuff still applies. So if I know it's going to be involving these points, what I'm really asking is which of these 3 regions actually works? What makes sense? So what I can do is I can actually try a little test value. All right, what if I plugged in negative 4? If I plugged in a negative 4, that'd be negative 4 plus 3 times negative 4 minus 2 is less than or equal to 0, and we're testing it. So that's negative 1 times negative 6 is positive 6. Where am I? All right, so we get 6 is not less than or equal to 0, so it's not part of our region. So let's look at a clean one all the way through for algebraically. Graphing wise is not that hard. Let's do something all the way through and then see exactly what it looks like start to end. So solve. X squared minus 2x is greater than 15. Okay, so what I'm going to do is I'm going to set it equal to 0 first. So that's x squared minus 2x minus 15 is greater than or equal to 0. Find your critical points. So the critical points are basically just the zeros. So we need to know when is this equal to 0. That just means solving this. So solve the result. You can use factoring. You can use completing the square. You can use quadratic formula. Use whatever is appropriate to win. You have to find those zeros. I'm going to use factoring because it's easier in this case. If you couldn't factor it, you'd probably have to go to the quadratic formula and get the answers that way. So I factor it. So minus 15, that's going to be x minus 5, x plus 3. And we're still saying when is this equal, greater than or equal to 0. So my critical points here are x equals 5 and x equals negative 3. It's the same process from when we solved via factoring. So thinking in terms of my number line, here's my negative 3, here's 5, and our answer is going to be some combination of these regions. So when I look at these regions, what I need to do is decide, okay, is this a region, is this, or is this? So I test value. I'm going to try out -4, and I'm going to plug it into our formula and see if it's true. So that'd be -4 minus 5 times -4 plus 3. And we're saying, is this greater than or equal to 0? So that's -9 times -1 is 9. 9 is greater than 0? Yes. So it worked over there in that region. If I tried in the middle, well, an easy test value would be 0. So let's plug in a 0, see if it works. That's 0 minus 5, 0 plus 3. And we're saying again, is that greater than or equal to 0 or not? So that gives me -5 times 3 is -15. And that is not greater than or equal to 0. So the middle region failed. No good. So let's try a test point over here just to make sure. So we try a 6. If I plug in a 6, that's 6 minus 5 times 6 plus 3. And we're saying, is that greater than or equal to 0 or not? So that gives me 1 times 9. We're saying, is that greater than or equal to 0? Yes, 9 is greater than or equal to 0. So it worked over in this region. So we know our answer is anything over here, and it can keep going. Anything over here, and it keeps going, but it doesn't work in the middle. My final thought is we match it up to these points. It was a greater than or equal to, so it would be a bracket or a closed circle. So my final answer here, I'm going to write out in domain notation, because it can be anything from -infinity all the way up to 3. So -infinity all the way up to -3 inclusive. Or it can be from 5 all the way to infinity. You can also use a union symbol to show that it's both put together. So this is a combination of what we did in the last couple lessons mixed with some of our older stuff. So I solved it, and I found out when that is greater than or equal to 0. It's anywhere in this region or in that region. Let's try another one, just so you can have a couple examples to look at. Okay, how about y is greater than x squared plus 7x plus 12. And our direction is to solve. Oh, no, let's make it 0. We'll keep it simple. Let's say 0, and our direction is to solve the inequality. So here, it's already, first step, set equal to 0, so we can work with it. It's equal to 0. I now need to find my key points. So when is that equal to 0? So x squared plus 7x plus 12 equals 0, and when is that going to be true? Again, completing the square, quadratic formula, factoring, whatever works. We have to get those values. So this here is again factorable. This is x plus 4 times x plus 3. It gives me x plus 4 equals 0, so x equals -4. X plus 3 equals 0, x equals -3. So my key points are -3 and -4. So here's -3, here's -4. I have 3 regions that are possibilities for my answers. So I'm going to start plugging in values and seeing what they'll work. So I'll choose a test value of -5, and I plug it into my equation. So that's -5 plus 4 times -5 plus 3. And we are asking, is this thing less than or equal to less than 0? So that gives me a -1 times -2, which is 2. 2 is not less than 0. It failed. That region is no good. All right, so we can look in the middle. Let's try -3.5. All right, so if we plug in a -3.5, that's -3.5 plus 4 times -3.5 plus 3. We're saying, is that less than 0? So that is, let's see, 0.5 times -0.5 is -1/4. Yes, -1/4 is less than 0. It works in the middle. All right, one final one. Let's try a -2. If I try a -2, that's -2 plus 4 times -2 plus 3. We're saying, is that less than or equal to 0? So that's 2 times 1 is 2. 2 is not less than 0. It failed over here on the right. And this is typically going to be your pattern. You're either going to get both sides, or we're usually going to get the middle. It's rare for it to be anything different. So in this case, it's only the middle. I come back up here. It was greater than up here. 0 had to be bigger than these, or that thing had to be less than the 0. So that means that these would be parentheses. So my answer would be -4 to -3. X is allowed to be anything between -4 and -3, but it cannot actually be them. All right, so on the homework for this portion, what you're going to have to do is you're going to have to just graph inequalities. So just make sure you're graphing the parabolas correctly and you shade it correctly. Then I'll ask you to solve via algebraically, typically is what I'll ask you to do. So go through, set it equal to 0. Make sure that you test each region, and then write out your answer, typically in interval notation. All right, we have one more thing to do. And this one's going to kill a bunch of you guys that did not do the work from last time. So oftentimes, we know that something is roughly parabolically shaped. We know it's going to be a parabola, but we don't know exactly where the vertex is or what the vertex. Maybe we just have raw data points, and we need to actually make that into a parabola. So say, for example, we have data points. We know that 1, 0, we know that 3, 2, and we know that 4, 0 are all on a parabola. We have to find out what the equation of the parabola is that fits all these numbers. Well, that's not so pretty. So here's our problem. Our general formula for a parabola is our y equals ax squared plus bx plus c. We need to be able to find out what the a, the b, and the c are in order to write out what the general form of the parabola is. Without that, we're going to be in trouble. So I'm going to show you kind of the main formal way of doing this. There are a couple shortcuts, but only if you can actually recognize them. So I'm going to show the ugliest one first, and then we'll come back and we'll revisit. So if we don't know anything about these points, we just know that they're points in general. Our only option is to plug each of these in as x and y. So let's actually plug in the first one. So y is 0 equals, my x is -1. So that's a times -1 squared plus b times -1 plus c. Okay, if we simplify that down, that gives me a minus b plus c equals 0. Okay, let's plug in this one. So that gives me 2 is equal to a times 3 squared plus, where am I at? 3 times b plus c. All right, so that gives us, again, if we reverse it, 9a plus 3b plus c equals 2. Finally, let's plug in our third one. So that's 0 is equal to a times 4 squared plus b times just that 4 plus c. Flip it around, we get 16a plus 4b plus c equals 0. All right, that was a lot of ugliness. We now have 1, 2, 3 equations. All right, this should start looking familiar now. If I write them now, we have a minus b plus c equals 0. We have 16a plus 4b plus c equals 0. And we have 9a plus 3b plus c equals 2. Hey, look, it's our friend, the systems of equations. Solve it. using substitution, elimination, Gaussian elimination, calculators, I don't care. Set it up is all the work you have to show me. You have to show that you have this part. And then you use whatever system you can come up with or find to help you break it down. Myself, I would dump this into a graphing calculator and then do reduce for echelon form and get the answer. So we put it into a device, put it into a calculator, or do it by hand if you have to. And then we can actually solve this out. So let's go ahead and do that. I'm actually going to put it in the calculator here real quick, and let's see what we actually get. So again, you should be putting it into the calculator. It's not worth the time to do it by hand. I'm not going to ask you to do it by hand. All right, so we would have 1, -1, 1, and 0, 16, 4, 1, and 0, and then 9, 3, 1, and 2. Okay, I've got it into my matrix. Can now go into math. Mine's a little bit different than your guys's. Reduced or echelon form of my matrix, which I think is stored as A right now. And we get that A would have to equal -1/2, B would be 3/2, and C would be 2. So my equation then is y equals -1/2 x squared plus 3/2 x plus 2. That's the equation of the parabola that passes through those 3 points. So looking over it again from the top, we have 3 generic points. If you don't know what to do with those points, you can't see any shortcut to help, then we dump it right into our generic form, ax squared plus bx plus c. Plug in each of those points to form a different equation. So I plugged in -1, 0, and I got this. I plugged in the 3, 2, I plug in the 4, 0. That gives me my 3 equations. Write it out as a system, and then solve that system, whatever way you want to. You can do it with substitution, you can do it with elimination, you can use a device which will use Gaussian elimination. I don't care. I'm not going to tell you to do it one way or the other on these. Just find the solution to that at that point and get these 3 points. The only work you have to show me is show me that you got the 3 equations and then that you were able to dump it in. Now, if you can remember some of our other forms, it makes things a little bit easier. So remember, we had standard form was our y equals ax squared plus bx plus c. But we had a couple other forms from those lectures. We had y equals a times x minus h squared plus k, which was our vertex. And then we also had that other one, y equals a times x minus p times x minus q, which was our intercept method. What I just showed you is the standard form method. It always works, it will always get the job done. However, if one of the points they give you is the vertex, then you should plug them into here because it'll be much simpler. If you know h and k, and you have a point giving you x and y, it's a lot easier to figure out what the a value is. If they give you intercepts, if you can figure out what p and q are, then it's going to be a lot easier to do this with that one. So let's go back and look at that previous example. These 3 points, well, we don't know if any of them are the vertex, so we can't use vertex form. However, -1, 0 and 4, 0 are the intercepts. That's where it's touching the x-axis. So effectively, I have p is -1 and q is 4. So we can come back over to this form. I know p is -1, I know q is 4, and we can plug it in. It gives me y equals a times x plus 1, x minus 4. That's a lot easier to work with. I know those 2 points are true, So now I can just pick the other point. My other point was 3, 2. So now I plug this one in. We've already put in the information from the two intercepts. All I have to do is put in another point. So I get 2 equals a times, well, my x is just 3. 3 plus 1, 3 minus 4. So that gives me 2 equals negative 4a. Divide both sides by negative 4. And I have a equals negative 1/2. That was a lot less work than the other one. I can plug it right back into this format and I get y equals negative 1/2, x minus 4, x plus 1. And I have an answer. That is an equation passing through those 3 points. So if you can recognize using the vertex or using the intercepts, it'll be a lot less work. If you can't, just go straight for standard form and it will give you the equation. So what I'm going to ask you to do total for all the homework today is you're going to have to do some graphing, graph some inequalities. Make sure it's shaded the right region, make sure it's solid or dashed. Second, you're going to have to solve some inequalities algebraically. So again, that involves you actually separating them. So making sure it's equal to 0. Find where those points are equal to 0, and then test each boundary to see what could be the answer. And finally, you're going to have to find the equation of a parabola that passes through points.